All right, folks. Thank you very much for joining us this evening. My name is Dr. Sarah Thomas. I'm a program manager at Wikimedia UK, and I'm helping to host this evening's Wikimedia UK training on making your first Wikidata query using SPARQL. It's Monday, the 16th of February. Martin Poulter is going to be leading us in our training tonight. If you have any questions during the session, then please do drop them in the chat and I can bring them to Martin's attention. And before we get going properly, I just want to remind everybody about our friendly space policy. As a Wikimedia UK event, we run under our friendly space policy. So the goal of this session is to create an encouraging space for collective learning. This requires intentional behaviour wherein participants are conscious of and accountable for the effect of their statements and actions on others. We respect our experiences and the experiences of others and recognise that we can't do this work without one another. We agree to hold each other accountable to foster a brave and friendly space. If you have any concerns, anything that you'd like to bring my attention during the evening, please use the private message function on Zoom. So without further ado, I would like to introduce our trainer for this evening, Dr. Martin Poulter. Martin is a trainer for Wikipedia, Wikidata and Wikisource, who helps professionals, students and newcomers to share open knowledge. He has held Wikimedia-related placements at the Halili Foundation, the Bodleian Libraries and the educational charity JISC. Over to you, Martin.
Thanks very much, Sarah, and good evening, everybody. Let me just share my screen. So, yeah, great to be seeing people again for the second session. Last time was about contributing knowledge to Wikidata. And in that session, I said why I think Wikidata is great, why it powers lots of things. So I won't be recapping that. We're going to be talking this evening. Well, we're going to this evening actually explore making Wikidata queries, which involves learning a language called SPARQL. SPARQL is the language used by these huge knowledge bases, not just Wikidata, but a lot of knowledge bases of this type. So last time I was saying that Wikidata is a platform for a hobby of nerd obsessions. People are obsessed with video games or historical figures or films and actors or scientific things, celestial bodies, archaeological finds, species. And Wikidata is an outlet for that. You can put in facts about that area one at a time, but do it regularly as a hobby, and then you find you've documented hundreds of topics in a way that can be reused on Wikipedia, reused across the wiki projects, reused in new apps, new visualizations. And what I hope we'll be able to do this evening, again, assuming no prior database knowledge, maybe some of you have queried databases before. Some of you have done some experimenting with Wikidata before, but I'm going to start assuming no knowledge of querying really, and we're going to build up, and hopefully you're going to have something kind of personalized and impressive that you can show other people and say, look at this thing I made, and they'll go, oh wow, it's interactive and it's really impressive. How did you do this? So why Wikidata is great, I'm taking as read. If you attended last time, can I advance my slides? And I do want to come back to the main kind of learning point of last time, is that all knowledge is represented in Wikidata in what are called triples. Triples because they're three things. That's an identifiable object, could be a person, could be a place, could be an artwork, could be a fictional mythical character. So there's the identifiable thing we're making a statement about. There's the property, which is the attribute, the aspect of that thing we're talking about, and then the value. So there's different kinds of triples, there's different kinds of values. So a value, if it's a height, it'll be a number plus a measurement. If it's a coordinate location, which we'll be using to make maps, it's a longitude and latitude pair. Dates are very complex in Wikidata. Dates can have different ranges. You can have like a day or a month or a year or a millennium, or you can have specified date ranges with start and end times. So that get quite complicated. A lot of statements in Wikidata are identifiers. So you take a person, Jane Austen, and she has this identifier in the Women Writers database and this identifier in the New York Times database and this identifier in the British Library database. Wikidata links all those different sources of knowledge. And it's important in putting knowledge into Wikidata or getting knowledge out to think in triples because it's like a simplified language. It's a language with a simplified grammar, um, and representing some things is difficult. It's unfamiliar in triples. I find it helpful to get a pen and paper and kind of draw out the relationships between things. Say if you're doing a family tree, that somebody is someone's spouse, and those people are someone's parents, and those children are parents of other children. It helps to draw it out to um, break it down to the individual relationships between different things. So I'm going to take that was something we talked a lot about last time, but that's really key, and that's going to be key to what we're doing this evening. And I'm going to go a bit further in. I mentioned that triples can have their own properties. So a triple can be the subject of another triple. For instance, context like often these are start times or end times or other kinds of context. If we say someone got a Nobel Prize or got a BAFTA or an Oscar or a Grammy, we're going to want to qualify that with the point in time where they got that award. So we can order there's this by year. And not what we're concerned with tonight, but references of another kind of triple. So a piece of knowledge can have the property that it's stated in a source. I mentioned there's qualifiers and references. There's another level of complication, which I skipped over last time, that I talked about last time as though the components of triples were were English phrases, but they're not. Wikidata is built in a multilingual way, in a really interesting way, and my camera is gradually slipping. That's an interesting thing for the camera to do. Can I wedge it in place? Okay. Right. We don't name things in Wikidata by their English names. This would lead to the Chris Jones problem, which is on the screen now. That if you look for authors called Chris Jones, well, there's a textbook author, there's a children's book author. If you look for people called Chris Jones, there's a footballer, there's a basketball player, there's a video game designer. They're not the same person. So a Wikidata item isn't identified by a name, it's identified by a Q number, Q and some digits. And all of the more than 100 million things in Wikidata each has a Q number. The properties have a P number. So properties, which, as we've seen, are things like date of birth or educated at or is a type of, those properties, they all have P numbers. So what's in Wikidata is a huge number of triples consisting of Q numbers, P numbers, and something else. So this is a fact in Wikidata. How is this interactable? How's this understandable by humans? Because there's another set of triples which are this thing is known in English as triples, or English label, we can call them. And of course, these triples are there for all the other languages. And of course, you can have multiple labels for each item, each property. You can have 40 different labels in English for the same thing, and then all the same labels in the other languages. So this adds a layer of complexity, but this is how it's truly multilingual. This is how I can be putting in dates of birth, and someone else is putting in birth dates, and then someone in another language is putting in date de naissance, or whatever it is in French, and we're all working on the same model. We're all working on the same data. Um, so, so for any of these one things like Ada Lovelace, there's lots of triples saying this is known in English as this is known in French as this, and so on. But this makes it, this is just something you have to bear in mind when we're asking Wikidata questions, that its knowledge is in the form of these Q numbers and P numbers and some other things as well, some values. And we've got to translate it. I've got to put some translation in place. Otherwise, we'll just get a screen full of numbers. Been through this. So I'm going to get quite quickly into actually doing hands-on exercises, and we'll start off really simple and kind of build up. And if you're way ahead of me, then that's fine. That you can personalize your queries. But yeah, if you find anything I'm doing a bit baffling, then stick closely and copy exactly what I'm doing. If it seems easy to you because you're already doing database stuff and you feel confident, then don't follow my instructions exactly. Improvise, look for, ask different things from what I'm asking, whatever you're comfortable with. I just need to talk about how you ask questions in this language called SPARQL. And it's similar in a way to how we make questions in English or any kind of human language. Take a sentence. So here's a statement in English expressing a fact. Jane Austen, English novelist, was born in Steventon. How would we make that into a question? Well, you can probably see at least a couple of ways we could make that a question. We take out something that's known and replace it with a placeholder. So it identifies the thing we want to know. So Jane Austen was born where? If we didn't know where she was born, you could ask the question. So the question's similar to the statement, but it's incomplete, and you kind of highlight the missing bit of your knowledge. And the thing answering your question is going to supply that bit, to supply the thing you said is missing. We could also do who was born in Steventon, another, so that's an incomplete statement in another way. Again, we've taken out something, we've identified the thing we don't know, put in a special placeholder word, who, what, where, and added a question mark. So it's a similar, a question in SPARQL is an incomplete statement. If we think of the statement we're just looking at, and I'm going to represent it with English phrases, just simplicity. So that triple is a statement. It's a piece of knowledge. How would we ask a question of that? Well, we replace one part of the triple with question mark and then a string, what's called a variable. If you do any coding or programming, you'll know the idea of a variable. But this is basically a name we give to the bit of information that we want to be supplied. We could do that with Jane Austen. We could remove Jane Austen and ask who has place of birth Steventon. So I will demonstrate asking that question. I'm going to go to, this is what we're going to be using throughout this session, the Wikidata query service. I've gone to Wikidata's homepage. Over on the side is a link called Query Service. That takes me to query.wikidata.org. So I could memorize that and often just type it in or bookmark it. But if I forget exactly what it is, then there's a direct link from any page in Wikidata when I click Query Service. This is the SPARQL. This is where I put my SPARQL incantation, and it's going to be read by the SPARQL genie. That's the way I think of it. We're asking a genie who's incredibly literal and only speaks this strange language of triples. And something that's going to be really helpful in using this interface is control space. Control space will bring up menus and suggestions. It's the auto suggest feature. So this is basically, this is blank at the moment. I'm going to control space. And then I have this menu of chunks of SPARQL that I can put in. The only one I need is this thing that begins select item label. So just to recap, I've come to this blank page, I can control space, and then one of the first things I'm suggested is this. So this is a bunch of text. It's a skeleton of a query. This does important stuff. I don't want to remember this phrase. I don't want to type it out each time, but it's going to be essential. We'll shortly see why it's essential. But this skeleton says select is the word that says what information do I want, what columns should be in the results. I'll explain what this long line of gobbledygook does in a second, but it's within this pair of curly brackets that I'm going to put my incomplete question. And my question was, who is born in Steventon? Oh, has that, Sarah?
Sorry to interrupt. I was just wondering, it might be helpful if you made your screen a wee bit bigger. Not, but yeah, there we go. Thank you.
Thanks for that. Right, yeah, if you have any difficulty seeing what I'm doing, then yeah, do. I can't see the chat right now. So thanks very much for that. Right. So I've created this skeleton. Within this skeleton, within these curly brackets is where I'm going to put my incomplete statement. And my question was, who is born in Steventon? I'm going to ask who is born in Bristol. I'm going to, but we don't type in was born in or Bristol because Wikidata has Q numbers and P numbers and expects that. So the triple is like who, I'll write out in English first, who was born in Bristol. So this first thing is a variable. It's the thing I want returned in the answers. It's what we're calling the item. So if I do question mark item, that's the first part of that triple. I'm saying that's a variable. That's the thing I want to know. How do we do birthplace? All properties will start WDT colon. It's Wikidata truthy. So it's expecting a P number here. You're not expected to know the P number off by heart. What I do is control space, and I can search birthplace, place of birth. And I can mouse over that. If I mouse over that P19, because I can't remember what that means, it'll tell me in English what that means and give a description. And now I've got Bristol. Well, Bristol is another item. Bristol has its own Q number. Items start with WD colon. And I'm going to do control space. And so I'm talking about the Bristol I'm in, which is in Southwest England. I'm going to avoid the one in the United States. And then after a triple, we put a full stop. So separate triples with a full stop. Bit confusingly, bit different from how English works. But that there is a question. And this big blue button runs the query. Which I'll show what happens. Depending on the complexity of the query, how many things we're asking for, it might almost be immediate. It might take several seconds. It might take a minute. It times out after a minute. So if we ask a really complicated question, like if we ask for like all people, it might time out. So it's worth asking about people, things with a specific quality. So I've asked for columns which are item and item label. So item is the thing that goes here, which is the Q number. Item label is the thing that's called in my language. So what this line is doing, that's doing the interpretation. It's saying Um, Whenever I have a variable name and then label with a capital L, put into that the thing that item is called in my language. Um, this is getting the auto, like this is getting the language from my web browser and detecting that it's English, and then it's using multiple languages. So if something has the same name in lots of languages, that's what that is, and it's using English as a ultimate fallback. Who are these people who were born in Bristol? There's another special label we can put in. If I put the name of my variable, which is completely arbitrary, it doesn't have to be called item. That's we just got to use it consistently. Um, then I put description with a capital D. So I'm asking the same question, but I'm asking more detail. I want the item, I want what it's called, its name, and then the one-line description. Again, big blue button to run the query. So just the list of names on its own is a bit like a category on Wikipedia. It's not hugely informative, but we could ask lots more properties of these people. We could ask their, I don't know, their birth dates and death dates and fields of work or so on. So this is a bit more useful. Um, this is telling me who these people are. And then it's linking to, clicking on the item will give me more information about each person. We can order this. So this isn't part of the question, but part of how it's formatted. After the final curly bracket, but let's order them alphabetically and not worry about surnames or first names. So it's going to take this second column, which is the name of each person, each result, and let's order that alphabetically. So it's basically the same question, just slightly different formatting. Big blue button runs it. So this is a really basic kind of query, and ordering these results alphabetically shouldn't take a lot of time, surely. Um, it tells me how many results there are, which is really helpful. And I should say at this point, so let's look at what some of these buttons do. What it's given me is this, it's kind of an interactive table. It's searchable. I can click in different places to order this, order by number or order by label. So the end user doesn't have to follow the default ordering that I've given. Oh, I can order by description, and then that'll highlight all the ones that lack a description. And sometimes it won't have an English or whatever language specified label for this thing. So it'll just give me the queue number. And so maybe the name of this person's been specified in another language, but not English. So I've got this interactive table. I can download the results. So if I wanted to paste this into a spreadsheet, TSV and CSV, comma separated variables are files I can do with that. They can be imported by Excel. JSON is a format that can be used by different kinds of software. If I'm a coder, not many people do this, I can click on code and get the piece of code which will perform this query in a bunch of different languages like Python and Ruby and R. So if I want to make an app that draws in the particular data about people or places or historical period or whatever, that's the basis of an app or visualization. Just make an interface to that code. So code and download. And what's really useful for sharing with other people is the short link function. So embed result, embed, that gives you a bit of code to embed this whole thing in a web page. So you can have, we're going to be doing maps and other kinds of visualizations later, and you make them in Wikidata and then kind of embed them in somewhere else in the web. But you might want to send this in email. If I do a short URL to result, that's kind of the most user-friendly. So that gives me a short link, and I paste that into another tab, and that cuts out all of the technical stuff and the SPARQL code and gets me right to the answers. Short URL to query will take me to this. So I should also point out that this is a highly multilingual interface. I'm using it in English, but you can swap out to a totally different language and it'll do the interpreting what the P's and Q's are, and it'll do the searching in that language. And sometimes you might want to see other languages. So you can set up a chain of languages. For some things, for some from Middle East culture, sometimes I want the name of something in Persian, but if not, then in Arabic. And if neither of those, then in French. And then if none of those, then English as a fallback. And that can be done by typing in the two-letter language codes. So what I put in here is it will look for labels and descriptions in this language, then this language, then this language. So this can be quite complicated and impressive. Someone in Oxford in a museum wanted a list of painters from before, I don't know, 1600. They had really good books and references about painters in the modern era, but they wanted kind of an authority file, a list of individuals known as painters from before that. And so I did this quickly, and it had 30,000, and it's searchable, it's orderable. I think I put kind of the nationality, some other data in, sent them that as a link. They're really grateful. They're really, how much effort did it take you to make this, to code this with searchability and all these 30,000 people in, all this data? Well, it would have been hard. It was hard before Wikidata came along to do that. But now I just want you to, because I've shown you some SPARQL code, it's already a bit confusing. I want to ask you to find people born, replicate what I've done. Find people whose place of birth is where you are. And if you're already thinking that's too simple, then find people educated at a particular university, educated at, find people, find something different. Feel free to be creative, or if it's really new to you, replicate what I've just done. So I'm going to cover up what I've done. Yeah, find people born whatever you are. I'm going to correct my typo in my slides. Find people that are whatever you are. That's a strange metaphysical challenge I've given. Find people born in wherever you are. And yeah, query.wikidata.org or follow the link from the homepage. Remember, the first step is using control space to get the skeleton. And then you put in your incomplete triple and you use WD : when you're finding an item, an identifier item like the place, Bristol, and you use WDT : to find a property. And I'm going to sit back for a couple of minutes and see how you get on with that. So you can, okay. Another helpful trick, just to revisit what I showed in this demonstration, this trick of putting the description. So if you've got a variable, which could be named anything, this variable is called item. If you put item description with capital D, that will get you this extra column with short descriptions. And that's a show-offy thing. I really only need English. So this is kind of the most basic kind of SPARQL query because we're only using one triple. We could use many triples. Triples can daisy chain, uh, like you instead in the author of the book about the battle in the war that blah blah, or they can be like a flower. You can ask for lots of one thing that has lots of properties. Um, the person who was female and a historian and wrote in the 18th century and spoke French. You can uh, ask for something that fits a lot of different properties or a chain of things. But yeah, can we have are people managing to get to this?
I think so. We have a couple of suggestions, couple of thumbs up. Yep.
Okay, I'll move on. Um, we're going to build towards making a map because a map is a more interesting visualization than this. So my challenge to you is list the world's art galleries. So go through the same procedure that we did. You can maybe adapt the query you've got. Um, uh, so we're not using place of birth now. We're using instance of everything that's an art gallery. Um, I'd better demonstrate this first, and then before you do it. Um, so here's my skeleton. Uh, we don't want a description for this. So if I was doing this from blank, I would again control space and get the basic skeleton. I want things that are art galleries. So item, the property I'm looking for is instance of. So everything should have an instant, every individual identifiable thing or place, organization, or whatever should have an instance of property. And then types or are items, they begin WD colon, and I said art gallery. So let's get the Q number for that. So I can run that. I'll get 4,000 that it knows of. A lot of these, a lot of really significant art galleries will be missing from this list. Some national galleries, some non-commercial galleries, and so on. Because there are galleries which are tagged, they're not instance of art gallery. They're non-commercial art gallery. So imagine you have a particular place in Wikidata as the property non-commercial art gallery. So you ask Wikidata for everything that is an instance of an art gallery. The genie is really literal. It's going to give you answers that exactly fit your question. And because art gallery isn't exactly the same thing as non-commercial art gallery, it will miss out the non-commercial art galleries or the national galleries or the sculpture parks or whatever. The things, the types, it'll miss those out. So it's the query that I've got now is only getting things that exactly match the property instance of art gallery. So there's a trick we can, well, an idiom we can use. Yeah, it's idiom because it's a language. There will be another triple attached to non-commercial art gallery that says non-commercial gallery is a subclass of art gallery. National gallery is a subclass of art gallery. So if I make this property a bit more complicated, I mean, I could get items of a type, and then that type is a type of art gallery. Like it could be done with two triples, but there's a shorter way to do it. If I take this property in the middle and add on another property, so it's going to be another WDT colon and subclass of. If I do type of, is that okay? Type of is another shorter way to get the same thing. A non-commercial art gallery is a type of an art gallery. So now this statement says, get me every item which is an instance of a subclass of art gallery. So that'll get all of the national galleries, the non-commercial galleries. If I run that, that won't get me the things that are instance of an art gallery. So a final step is to make this bit, this subclass, optional. And that's what a question mark does. So now this says, get me the things that are an instance of an art gallery, and also the things that are instance of a subclass of art gallery, and that'll get the national galleries and the commercial galleries and so on. So the straightforward thing asking for art galleries gave over 4,000 results. Adding this extra bit, this is going to be useful if you're looking for libraries or universities or um, uh, making all kinds of maps. It'll take a bit. Okay, I'm getting more things. I'm getting more than 5,000 results now. Yeah, this is a place to start. So at the moment, we have a kind of a boring table, but we're going to get, yeah, we want images. We're going to make an image gallery later on. I said triples should end with a full stop. That's from the Quix's language. So let's ask other things. Item. So I start another triple. What's another property I'm interested in? Image. All properties are WDT colon, and it's with small letters. Well, I don't want a specific image. I just want the Wikidata to give me whatever images it has. So this next bit is a variable. So I can call it anything. I'm going to call the variable image, but it could be anything as long as I use it consistently. Yeah, I'm going to call that image. And then this first line between select and where it says what columns, what things do I want shown in the results. So I want the image shown. At the moment, it will just show the file name of the image. These are all images on Wikimedia Commons that are pointed to by Wikidata. So again, big blue button to run this. Now there's another image. So there's another column with the image with the Commons link. We've got fewer results because not all art galleries have an image attached to them. Yeah, I'll show the next bit. So I'm interested in art galleries whether or not they have an image attached to them. So we've seen about a quarter do, most don't. So I don't want to specify that there must be an image. I'm just interested, like, give me an image if you have it. And the idiom for that is optional. I mark this particular triple as optional. So without this phrase, without the keyword optional and the curly brackets, that would be mandatory that you only give me art galleries that have an image in common. With optional and the curly brackets, it's saying give me an image if you have it. I'll run that. And so I should get 5,000 plus results, about 1 in 4 of which will have the image attached. There we go. So I'm getting the art galleries that have an image and also the ones that don't. It just leaves the column blank. So I want you to get to this stage. I will, yeah, I'll go back to the, yeah, see if you can build what I just had there. Instance of, and the slash and the type of. And then we found it useful to put a clause in optional and to put that around. So, and the statements that we did that with, the property was called image. I'll give you a few minutes to work on that, and then we'll talk about building up your own library of queries and how you kind of remember all this stuff, because I don't remember all this stuff from week to week when I'm doing it. So how you build up a personal library of queries you can keep going back to remind yourself. Screen. So this is my query for a list. It's returning images as well. Um, so something you can do with images. This box here selects how you display the results. The default is a table, but there are other options. So if there's numbers, if there's numerical data being returned, that could be a bar chart or a line chart. If there are connections between things, they could be a graph. But one that's relevant to this query is image grid. So I can view the same set of results, but something nicer. So I'd like a way to set this permanently so that if I send this query to someone else, they see it as an image gallery, not a boring table. And for this, I go to the start, the first line, I create a first blank line of the query and type the hash key. So now it auto suggests, this isn't part of SPARQL, this is just an instruction to the interface. There's different possibilities. So I go to the blank first line, press hash, have these options, and that will force the results to be given in this particular format, a map, a timeline, whatever. So I'm choosing image grid, and I run that. Now I get the image grid instead of the table. And now if I do the link and short URL to result, then I send that link to somebody, they will see the results in this image gallery format. So I've jumped into a few things there. I've jumped into getting images, having some information be optional, and this kind of instance of subclass of idiom, which saves a load of time if you remember to do it. And but you can see quickly there's a lot of different tricks and idioms and kind of quirks of SPARQL, and you're not expected to learn them off by heart. So I want to talk about keeping your queries for the future. Find some text format, could be Notepad, could be Google Doc, something that can take a lot of text and be searchable. When you get a query that does something you like, paste your query in there and then give it a title, maybe a description of what it does. Just put in a line of text like, what did this manage to achieve? Maybe you made a map, maybe the timeline, maybe you made an image gallery of museums. I find using my Wikidata user page ideal because there's a way to format the queries properly with a template, but also because it's a wiki, it tracks the revisions. So I can improve my queries. I can edit them over time as I learn more, build up a huge list. And whenever I want to remember how I did a particular thing with dates or images or locations, whatever, I can just Control F or Command F in that document and find the thing. I might think, oh, I'm trying to do this particular thing, but it was about art galleries. But I want to make a similar map. I call up my Wikidata user page and then search through and then find that query, but then adapt it to the other thing I want to make. Maybe I want to make a map of libraries or map of museums or universities or so on. I just find it incredibly useful. And yeah, you're not supposed to remember all this stuff carries around in your head. And these user pages that people put up on Wikidata, they are in the SPARQL category on Wikidata, and they kind of link to each other. So you can find queries that other people are working on and crypt them, and adapt them to whatever you want to do. And sharing on social media as well. I mean, it used to be on Twitter, which a lot of us have done an exodus from, but you can share on social media and see what kind of new queries people are coming up with, new, just clever ways to create this huge knowledge base. Um, so we've got some basic queries. We've got um, images, and we can make an image gallery. A really interesting one query we looked at last time was like self-portraits of women. So we could ask for things, instance of a painting, of genre, self-portrait, and then we could ask about the creator of the painting, and then we can watch that image gallery return more results over time as more paintings are described in Wikidata. We've been going for about an hour. I think we should take a comfort break and then come back and develop our galleries query further and make it more interactive and more information and make it a map. So you can show people an interactive map that you've made. And if you want to work on something that's not about art galleries, but something more your interest, you're welcome to. But yeah, I think we'll stop for a bit.
Cool. So that's us 2 minutes to. So I'm going to say if we come back at, say, 5 past. 5 past the hour. Okay, folks. See you in a few minutes.
Okay, thanks everybody. We've got to making some basic queries, uh, getting results, sharing those queries with a short URL, an email, and social media. And we've talked about different ways to visualize the same set of results. Um, so the default is a table, but if it's numeric, it could be a chart. If it's images, it could be an image gallery. If it's dates, it could be a timeline. So my next challenge, yeah, let's get some dates in our data. So the property for the when something started to exist in Wikidata is called the inception. So we're going to add another. So I will demonstrate this, and then I'll ask you to copy. So another bit of information. So yeah, I don't want the image grid right now. I'm going to go back to the table view, but we're going to add another column of information. So I've got to add another incomplete triple here, and then I've got to add the variable name after select to tell me to include that in results. So, uh, so the additional triple is we're still talking about the same item. Item is what we're calling the art gallery as we're getting. The new property is inception. Properties are always WDT colon. That gets me the P number for inception. And remember, I can mouse over if I forget what these P numbers are. And then, well, the date is a unknown thing. So we can, it's another variable with a question mark. And then we can call it in, I'm going to call its date. And I've mentioned date objects in Wikidata are really complicated. They have like levels of precision. We really only want the year. So I'm gonna say, so if I run this now, date won't appear in the results because date isn't mentioned up here at the top. So I can put date up here. So I've got to spell it exactly the same way, consistently. But I just want the year, so I can apply what's called a function to this. Year, capital letters, and then round brackets, will get the complicated date object with different levels of precision and just boil it down to the number, which is the year. And so I've created a new variable. So I've got to name this new variable. which I'll call year. I could call that anything, but that's just a sensible name for it. And then this whole expression I put in curvy brackets.
Did I get you to zoom in a little bit again, Martin? Sorry. Thank you.
Okay. Is that okay? Right. Yeah, sorry, I don't know what screen sizes people are on. Yeah, this is a bit helpful, isn't it? So I'm asking for the item, which is going to be the art gallery, what it's known by in the language I've specified, an image if one exists, and this is taking the inception date, the date when it started to exist, and this expression transforms it into a year. Let's run that. Because I haven't put this as optional, it's requiring that only return me results if you know the date, the inception date. So a couple of thousand art galleries are missing because Wikidata doesn't know the inception year. But I have inception years from a wide time period. So another thing I can do, again, this relates to not what data I'm getting, but how I'm presented the results. After that final curly bracket, I can do order by, and then the number or the alphabetical order. So I did this earlier to get an alphabetical order. Here I'm interested in date order. So order by year, and I run that. And now I see the earliest to latest founded art galleries. So I can do this in the results by clicking here to order. But putting this clause kind of makes it part of the query. If I'm going to send this query to someone else, it might be really important that they get the earliest, the oldest art galleries first. Another shall we introduce filtering? Yeah. So I mentioned I was asked for artists from before 1600. And I might want to filter my results to just a range of interest. So I might be interested in people with a particular range of birth dates, or events that happen in a particular day of history, or I might be interested in measurements, sculptures that are more than a certain height high. So I want to restrict by a number, basically, like a date. So let's say art galleries that, yeah, but from before 1700. And the keyword for that is filter. And I think this takes curly brackets. So again, dates are complicated. I'm going to simplify the date. I almost always simplify the date using this year function. And I'm going to do is less than, what did I say, 1700. So this is of the results we've got so far, only show the ones which have this property. So I've taken the date, I've reduced the date to just a number. BC dates will be negative numbers, so they will show up. And then I've just taken an arbitrary cutoff date. Now I have very few. So I was only interested the oldest galleries with known dates when they were established. So I've only got 14 results now. I've filtered them to ones which this statement is true, that the inception was before 1700. We'll use that later on. Yeah, we'll come to filtering again in a bit. What I want you to do now Oh, if I put this hash mark at the start of a line, it turns it into a comment. So it deactivates it. And this is a useful thing to have in queries because there might be different variations I want to make of the same query or the same map. There might be different additional properties. So I might write a lot of things into my query, but not all of them are active at once. I might want to deactivate them. So here I've deactivated the thing about the inception date. I'll deactivate the filter. So now this bit is just null text. It's being ignored by the Wikidata query. So this is asking for art galleries, the name, the image. We're still asking for the inception date. Let's ask for some other properties. A really useful property, if we're going to make a map, is called coordinate location. Property is always WT colon. So I control space, start typing coordinate location. And again, I'm not specifying a coordinate location. I just want to know whatever coordinate location it has. So this is going to be another variable. Just call it coord. Could be anything. Could be lat long. And again, this won't return in the result unless I specify on that first line that I want a column for the results. So now I'll run this. So I'm asking for more properties, and we could ask for quite a lot of properties of the things that return the results. So now I'm getting inception dates. I'm no longer filtering, and I'm getting latitude, longitude. And this isn't a pleasant way to view these results. But if you have coordinates in your results, then map visualization is an option. So now I get, and because there's images in the results, if there's an image, it'll give me a thumbnail. So this is a lot more interactive. I mean, so we've included results where it doesn't have an image, so it won't always have an image. What would be a more useful property to have? What might not gallery have? An official website. So again, another triple. And the property is official website. And I'm not looking for specific official website. So that's a variable. I say whatever official website you have for this item, this art gallery, let's put that in. So again, I've got to put the variable in the top line if I want it to be returned in results. And in fact, we don't need to order by now because the order isn't visible because they're being displayed by latitude, longitude on a map. And I don't want to every time change the display format to map. So I'm going to put in on that first line. Again, to select the display mode, I go to a blank first line and tap the hash button, and that brings up this menu of different views, and I'm going to choose map. So now when I run this, I will get a map straight away. And it must be caching the results. So will we see? Okay, I should maybe zoom in. What's near me? So multiple galleries in the same location will have a different size of. So now we're getting year of establishment, photo image, and link to the official website. So this is, honestly, this has been hugely useful in my career when somebody says they're working on something, and I say, "Oh, here's a interactive map of those things with links for further information and images," and I make it over a lunch hour and I send it. Um, that's just really, even if it's incomplete, even if somebody says, "Well, there's loads of art galleries in France and they're missing from here," uh, that's a starting point. That's a starting point for adding stuff. I think Wikidata labels some things that I would call art galleries as art museums. There's like a slight difference in terminology. So um, I think there are things I would call art galleries that are not appearing in this view. But we're getting thousands of things. We're getting results from around the world. But I'm going to ask you now to replicate what I've done. So I'll recap what I did. I asked for, well, the important thing for making a map is asking for the coordinate location. So you've got to have a property, which is coordinate location, and you've got to have the coordinates being returned in the results. So you've got to mention whatever variable you choose in the results. You can have other properties like official website. That's got to have its own triple. And it's helpful to have an image. We've shown how to have an image. I could have made, yeah, I should make this optional because if an art gallery doesn't have an official website known to Wikidata, we still want to see it on the map. So that'll bring more results. It's my choice, really. It's the choice you set up. Do you want uh, only results which have all the properties you're interested in, or do you want to make them optional? You know, tell me it if you know it, but if not, still give me a result. Um, so you've already got the art gallery query. Add other things to it. Hopefully, you've got the image. Definitely get coordinates and make it a map. So create that first line, press hash, the default view map. Um, Again, I'll make it harder off the screen. Yeah. So yeah, you uh, if you're following this closely, you have a map of art galleries with little images and further information and uh, official URLs that pop up. And um, remember, if you send this link to somebody, they'll get all this code before they get the map. If you click on link and do short URL to result, that short URL will take the reader directly to the map. So you show them this map you've made. Um, uh, yeah, if you've got a map you're happy with, copy the query code into something, save it, and you'll uh, come back and adapt it. Or like I said, use the template on a Wikidata user page. Okay, I've got a challenge involving filter. I showed you how to filter, and filter you can compare uh, two quantities. So if I put in this filter statement, this compares the year of the date to 1700, only shows results uh, where that's true, only shows art galleries older than that inception date. So another application of that, so my challenge is to make an image gallery, but find landscape paintings taller than they are wide. You know, the joke about the National Portrait Gallery has art which is tall and the National Landscape Gallery has art which is wide. There is art. I thought all landscape art would be kind of wider than it is tall, but that's not true. There's landscape paintings taller than they are wide. I've mentioned that measurements in Wikidata are a number and a unit, but we don't have to worry about the unit because the same units will be, for a given painting, the same units will be used for the height and the width. So we just want the height to be taller than the width, and we don't bother about the unit. Landscape is a property of genre. So genre, landscape, art. I've mentioned a painting can have, genre like portrait or still life or whatever. And the things we're looking at are now not art galleries or people, they're paintings. Yeah, I'm going to leave that to you as a I'm going to leave that as a challenge for a few minutes, and then I'm going to come back and do it. Yeah, have a go again from the blank query interface, control space to get the query skeleton, and then to start putting triples in with the properties that are on the screen. And just see how you get on. This is more difficult than what we've been doing so far. Sarah, do you want to stop the recording for a bit? Right, I'll do this from scratch, find landscape paintings taller than they are wide. So this will be a new tab. So from a blank query, I get the skeleton. So landscape paintings, there's going to be two triples that define that. I'm looking for things that are paintings and things whose genre is landscape art. So as always, properties are WDT, uh, instance of, and then painting is an item in its own right. Painting, I've got to distinguish painting as in a visual artwork from the activity of painting or from painting as in decorating your house. So that's one triple, and I put a full stop after that. Another triple define the genre. So I've got to creative works genre, and I've mentioned it's got to be landscape art. If I say landscape, that means the visual feature of land, not a type of painting. So landscape painting, and remember I can mouse over these to see that I'm getting the right thing. Then I want to know if it's tall and it is wide, I've got to get the height and the width. So these are all properties of the same thing. So, and then the height is a variable, so I'm going to call it height. And again, height as in the length of an entity, not as in how high it is above sea level. That needs a full stop. And I want the width. Width of an object, yeah, not the width of a ship. That's got to be another variable. I will call it width. Again, it could be anything. And so how do I only get art that's taller than it is wide? That's what the filter statement is for. And filter takes curvy brackets. And I'm just assuming that they're in the same units because they pretty much always are. So height is more than width. And if I do this, this will just give me a list of names of the art. I actually want to see the art. So I'm going to ask for the image. So I think that's right. I don't want to see the height and width in the results. So they can be calculated. Sometimes it's useful to calculate things, but not show them in the results. But I do want the image in the results. So everything that's got to appear in the results has got to be on this first line. Let's test that that does get some results. I've not made any typos or oh, it's a lot. So I'm getting names of art and some images, but I want to see it as an image gallery. And to set the result, sort of the view into a particular type, I go to that first line, type hash, image grid. Run it again. So you can see I can add lots more triples to this either to get more properties of the thing or to really specify the kinds of thing I'm talking about. Maybe I only want paintings from a particular time period. That could be another filter. Or I want paintings that are in a collection of a particular museum, or paintings by a particular artist, or so on. But there we go. And there's always new figures in all my queries, and it's great. So some of this is dubiously landscape art, or some of these images are probably extracts. They're probably not the entire painting, but a detail from it, which is why they're in a funny ratio. So there you go. You imagine finding thousands of images of landscape art the conventional way by going to a gallery or museum websites. Like, how would you even search for landscape art that is tall than it is wide? You could do typing in that phrase to a search engine probably won't help. You'd have to look at lots and lots of art catalogs and compare height and width to get that. But I can just define the kind of thing I'm interested in and say I want images of it and make an image gallery and send off to someone else. Phew, that worked. That I didn't make a typo. Live demos so often go wrong. Counts. Do we want to do counts? I think rather than going through my kind of list of tasks, because we're coming to the last section, I want to talk about how you stay in touch with the community and how you learn further and how you develop further in how you develop further in SPARQL, how you get better. But are there particular kinds of queries? Are there queries on people's minds, things that they want to know how to do, that they want to put in the chat for Sarah to, or share an audio? We could do counts, we could do a bubble chart, but that's the kind of, I don't know if you want counts of things. Sorry, Sarah.
Oh, no, I was going to say, we have a question from Eric. How do you filter for labels, names in certain languages?
Great. Multiple ways to do this. I'm thinking, so okay, I only want English names of, so I only want there to show results if Wikidata knows the English name for the thing. And I said that won't always be true because sometimes the label's in another language. So I don't use this. This invocation, again, which it's just part of the query skeleton, you don't have to remember it, will kind of automatically create labels and try to find labels in a sequence of different languages. Okay, I'm going to comment this out. So if I put that symbol at the start of this line, this is now inactive. This is now a comment. And the property, so it's a different kind of property. It's not a WTT property. I talked at the start about how this is known in English as properties. It's called RDFS label. So item is the thing in Wikidata, the property RDFS label, and then the value of that property is the thing we're calling item label. And you're right, it's a filter statement. And so we've got another function which returns the language of a string. And then the names of the languages aren't like the full name like English or French or Swahili or whatever. They're the two-letter language code that we use for like naming Wikipedias. And so from my memory, And people go, oh, why is this RDFS? And what does RDFS stand for? And why are these things WDT? And the answer is, but there's such a complicated history behind this, different standards bodies setting different standards, that it's just best not to know. It's best to just make a query that does this, and then just keep it, like I say, keep it in your file of queries.
I remember
It's
very
not worth it.
distinctly, Martin, you telling me
Yeah.
at one point, and me getting quite frustrated and going, "Why is it like that?" And it was like the answer is
Yes.
just it's just
Yeah.
one of those things you just have to remember it. And I was like, "Oh, okay."
These are open standards that have been hacked together over the decades by different standards bodies and different committees. And some things are schema colon something, and some things are RDFS colon. And yeah, you don't learning it will not help you be good at SPARQL. I've got rid of the image grid aspect. Yeah, we should talk about the query helper. That's useful. So it's providing English labels, and it's only providing results if it knows an English label. Um, so that's kind of the hard. Yeah, sometimes I want to know the labels in another language. I want to get Arabic labels for something, but I want a column with, um, yeah, I want to know things that are labeled in English but not in Arabic. Uh, that so I can give that to Arabic translators. So that's when I'd use this kind of query. For most queries, you just use that automatic service which generates labels. Um, so yeah, RDFS label and then a filter for the particular language. We should look at what the query. Yeah, it won't work well with filters. Um, okay, I'm going to comment this new bit out, reactivate that service. So now it will give me all results, whether it has an English or not, and then just show what the query builder does. No, not the query interpreter. The query builder is really basic, and yeah, it does very, very basic kind of queries. We've already gone way beyond what it can do. But something that's well worth looking at is the query interpreter. Oh, which query explainer? Right, the query helper. Got the terminology confused. So this, I should have actually this earlier. This attempts to render in English what this query does. It gets confused by more complicated queries. See, it's not mentioning the filter. It's not mentioning the height got to be uh, greater than the width. So it's not interpreted all of this query, but it's rendering it in English. But the cool thing is that this works both ways. So if I edit this English description, it will change the query here. So now I want self-portraits, portrait painting that is taller than it is. Right. So yeah, representation of an artist. And now I've made that change. It's changed my SPARQL code. And well, portrait painting, the height is going to be greater than the width. That's going to be the default, isn't it? So I'm going to switch the direction. So I'm now asking for self-portrait paintings that are wider than they are tall. So that's kind of helpful. This helps you adapt a query. Um, if you're really comfortable with SPARQL, if you use it a few times, you don't need it. But this can help you adapt. Yeah, if you find a SPARQL query somewhere else, uh, and you're not sure what all these bits are doing, activating the query helper can help you with that. But let's get our image grid of portrait paintings that are wider than they are tall. Okay. And this is a really important learning point from this session, that a query that works and does something can be quickly adapted into a similar query on a different topic or a different type of thing. So a lot of what we do as the Wikidata community is share and adapt each other's queries, and that's how we learn. I'm constantly learning from SPARQL wizards. There are people who tell me they're learning from me. We're all sharing stuff, and we're all, yeah, adapting stuff on the fly to make it relevant to whatever our interests are, whatever we're working on. Yeah, this is kind of messed up a bit, but yeah, what I just did there allowed me to rapidly change this query into something else. And I've mentioned a map of art galleries could become a map of universities or a map of libraries, whatever, quite quickly. Yeah, I
Sounds
wanted to
found.
talk.
Oh, sorry.
Yeah, I want to talk a bit about that. Um, there's more things that have a query service, not just Wikidata. There's yeah, maybe that's a bit nerdy to do, but you can ask Wikidata for other things that have a query interface in a kind of reciprocal. But to mention, yeah, examples, I should show you where the examples are. The Wikidata Weekly newsletter I mentioned last time, there's always new queries in that, new queries that people are working on. You can request a query. This is a really helpful notice board. People at all levels of confidence with SPARQL are visiting. So you will get wizards asking for help from Uber wizards and beginners asking for help from experienced queries. So go there, help somebody with a really basic query, ask for help with the query you're finding difficult. I find the best list of functions. We saw some functions like year, turning a date into a year. There's a couple of those. There are string functions, so you can search for a string within another string. So you want names that contain a particular string. And this Wikibook, I find genuinely the best, most helpful resource for that. It has all the functions on one page. The examples, so there's a page on Wikidata with the examples, but they are also built into the query service function. So I've just talked about adapting a query. And once you know that, then this is really useful. So there's this button for examples at the top. Okay, map of hospitals. Uh, humans born in a particular center. So what's a thing we can uh, uh, okay, some of these are about language. Some of these are right. Some of these are massively complicated. It's often complained that there's a massive learning curve to these. The first few examples it gives are really straightforward, and then it jumps to uh, cats, and then it jumps to really complicated. So this is one of the simple ones. Remember, we can mouse over to find what these are. So item this means instance of cat. So that is the triple which gets you identifies cat. And then this idiom where you don't have a full stop, you have a semicolon, means the next statement is about the same item. So this triple, this is the same as putting, it's exactly the same. It's two triples, but it's just, well, slightly fewer characters. Uh, so this, we're on the internet. It's easy to get pictures of cats. Um, again, we can adapt this. I can replace this with something else. Well, okay, the title's the same because I didn't change the title in a confusing way. Um, but a query that does one thing can be adapted very quickly into a query which does a similar thing. Okay, I'm going to get rid of that title thing. And a way I could have done that with this simple query is with the query helper. So that makes it rapid to change this query into something else. Yay. You can have a lot of fun with just that query looking at different lovely animals. Um,
We have one question in the comments if we have time for another more.
sure.
Oliver Sola is asking, can you make a query for subjects without a value, say art museums without an official website, in trying to identify a gap? So I think the answer to this
Yeah,
is that
good.
it's
Yeah.
minus. Yeah.
Okay. So instead of optional, that's a really useful question. Um, if I replace that keyword optional with minus, so when I have the triple and there's no keyword around it, it says, give me results that have this property. If there's optional around it and the curly brackets, then give me the results whether or not it has this property. Give me an image if you have it, but if you don't have the image, I still want results. Minus will say, if this has a value, don't give me the results. So this clause is saying, look for an official website for this art gallery. And if you know of an official website for this gallery, then don't give me results. So minus is pretty useful. Yes, especially if you want to add stuff to Wikidata, find out where it's incomplete, find activities that could improve it. I don't want this to be a map. And right, it's returned me a list of art galleries it knows about that do have coordinates, that do have an image, but the official website is blank. So minus is a really useful keyword to have. Thanks for asking that. That was an important thing to address in this session. And so I've gone from really basic. We've got quite challenging in the things that I've been doing, and so I hope you've. It sounds like people are carried along, and it sounds like people are experimenting and finding other things they want to query. And as always, stay in touch. Stay in touch with Wikimedia UK. Stay in touch with the Wikidata community. Use the notice boards on the Wikidata site, and as with all things wiki, you can ask for help. And we're all asking for help, and we're all uh, learning, getting on to the next stage all the time. Any other questions or things people would like to do, but they're not sure how they would do?
No, just people saying thank you, and this has been
Oh,
really useful.
oh.
Donald is stuck in an infinite wormhole.
And if you're, yeah, a lot of people here tonight were in the session last week. So if you've been putting in, um, if you've been, yeah, putting in characters to the Moomin universe that Johanna was last time, or we putting paintings in Indian paintings into Wikidata and culture diversifying it, then you can make a query that we could um, make a query that shows your progress, or yeah, that's suggestion. Make a query that shows things that are missing, a particular type of thing, but a property that's missing, so you can look for its official website, or maybe it's missing a coordinate. You can find the coordinates in Google Maps, put those in, and it'll appear on the map. So a bit of querying and a lot of adding data to Wikidata can be a fantastic hobby.
Wholeheartedly agree. All right, folks. That's us coming just up on the hour just now. So I'll just invite everybody to give a virtual round of applause to Martin. Thank you very much. This was
Thank
great.
you all. Thank you all for spending this time, I think it's 2 hours on a Monday evening with us.
Love
And
it.
thank you, Sarah. Excellent hosting as always.
All right. Thank you so much, everybody. I'm going to stop the recording and we shall see you soon.